The next question concerns a boat moving upstream at 12 miles an hour. That's the speed of the boat as it moves through the water. But the water is flowing this way at a speed X miles per hour. Okay, so what's the speed, actual speed of the boat relative to the towns and countries and objects it's passing? Okay, how fast is the boat moving relative to the land? Well, if it's moving 12 miles an hour this way and the current's pulling it back 3 miles an hour this way, it seems that the speed should be 12 minus x, and that's exactly what it is. Now, we ask then, for how long does it take this boat, what's the expression for how long it takes this boat to travel 6 miles? Okay, now we have to digress a little bit. How do we figure out the time it takes to travel if we know how fast we're moving and how far we're going? Well, think of an example. If we're doing 3 miles an hour, how long does it take us to go 15 miles? Okay, well, pretty clear. The answer pretty much pop into anybody's head. Well, 3 miles every hour, 15 miles is going to take 5 hours, because 5 times 3 is 15. That's common sense. Now, what did we do? We need to abstract that a little bit to the process that we use to figure out how long it takes. And what we do is we divide how far we're going by our speed. 15 miles an hour divided by 15 miles divided by 3 miles an hour gives us 5 hours. Okay, so we're going to have to divide the distance, which is 6 miles. I'll just represent that with the number 6. In physics, I nag people very hard to use units. Here, we're not going to worry as much about it. Okay, 6 miles, so we divide how far by how fast. 6 miles divided by 12 minus x miles per hour. That's distance divided by speed. That's how we calculate the time to travel. So the answer, once we understand that dividing distance by speed gives us the time of travel, is fairly obvious. Divide the distance by the speed. Okay? And the time to travel then, what if we're doing 6 miles downstream? What if we turn around and go back this way? Okay, now we're going downstream. How fast are we moving? Well, we're still, our motor's still moving us through the water at 12 miles an hour, but we're going this way, and the current is 3 miles an hour this way. So the current is also carrying us at an additional, well, it's not 3 miles an hour, it's x miles an hour, I'm sorry, at an additional x miles an hour. So our speed is going to be 12 plus x. And it follows that the time is going to be distance over speed, 6 over 12 plus x. Now, that should be very handy in subsequent questions that we didn't get over in class and that we'll be talking about in our next class. Another example over here. Speed is 12 miles an hour. Then how long does it take to go the 6 miles? Well, it's going to be a half hour, half of 12 miles, and so forth. But also, if we divide the distance by the speed, we have 6 over 12, which is 1/2. Half hour time to travel 6 miles at 12 miles an hour. So, at 12 miles an hour, it takes 6 over 12 hours. At 12 minus x miles an hour, it takes 6 over 12 minus x hours. At 12 plus x miles an hour, it takes 6 over 12 plus x hours. Give you a little bonus here. If the current is x miles an hour, then if we go 6 miles upstream, 6 miles downstream, our round trip time is going to be 6 over 12 minus x, the time it takes to go upstream against the current, plus 6 divided by 12 plus x, which is the time it takes to come back with the x mile an hour current helping you. That could be very useful. Okay, the last question we dealt with in class was, if it takes somebody 4 hours to do a job, then what fraction of the job do they do in 1 hour? Now, that answer is, to most people, was really pretty obvious. Okay, it takes 1/4 of the job gets done in 1 hour by a person who needs 4 hours to complete it. And if a person needs 6 hours to complete it, what fraction? Well, 1/6. So then, how much of the job gets done in an hour if both are working together? What do you think about that? And think about it before I move my hand and then cover the answer if you haven't already seen it. Well, if this person does 1/4 of the job in an hour and this one does 1/6 of the job in the hour, then working together, they do 1/4 plus 1/6 of the job in an hour, working together. And that's going to be quite useful.